Good morning, everyone. Welcome to the morning programming stream. It is Monday, November the 18th, and we're going to start things off really excellently today with a nice cup of English breakfast tea, straight from the township of Canterbury. Look at that beautiful deep red color. We're going to take a nice sip of that. And we will jump right into things here today. Big change of pace from where we were at yesterday, for the better. So, take our sip. Now we're ready to start the day. Okay, so yesterday, if you caught the Sunday stream, here is Spotify. I spent a couple of hours trying to set up the Go compiler on my laptop here. And I was able to set up the compiler, but I was having a lot of issues trying to install any package, basically, from using the Go package manager. And namely, I was trying to get Go Please, which is the Go LSP, installed on my computer. It was failing over and over again with like these very bizarre errors, like being unable to find Go standard libraries that were definitely were definitely in Go path, um, and I was like very confused what was going on. I tried like a couple different versions of the Go installer. I went to the Go Discord for help, and I tried reproducing the issue on one of my other computers, and basically for some reason I have this now unreproducible error where on current latest Go, which is 1.23.3, this computer uh, cannot find the Go standard libraries in path for whatever reason. Just with no like funky stuff going on after like a fresh install straight from the Go website. Um, any other version it can. Any other version of Go I installed worked, and this latest version also worked on other computers that I had, installing it from Winget or Chocolatey or whatever. So I was like a little freaking baffled there, and I don't know exactly what the problem is. I do admit the first time I installed Go and and tried to install Go Please, my computer did uh, like blue screen in the middle of it. My computer's been blue screening because I changed the laptop battery, so Windows is freaking out trying to retrain itself against the new battery capacity. Um, but I did would I did not know, or I could not find anything that would any state on the computer that would have actually gotten stuck um, from Go after rebooting after that blue screen. I cleared out a completely clean uninstalled uh, the Go compiler package manager. I blew away the package cache like locally. Looked through the registry to see if I could find anything. There wasn't anything there. Um, Blew away environment variables. Rebooted again, and still like there's just something stuck that I that is from that from that problem interaction. That means like that specific version of Go just does not work on my computer. That's really annoying. Because I spent like all day trying to frickin' fix the issue, and then trying to reproduce and isolate it to see if it was an actual um, bug in the current Go installer. Because that would be terrible. That really bad if the currently released version of Go is like had a bug for like the past 10 days it's been out on Windows. I don't know what the makeup is of the average Go developer. If they're mostly running Linux or Mac or whatever. But that would be like horrendous if that did slip through the cracks. But I went through uh, I said some things maybe I shouldn't have about Go that probably were some like creepy, honestly probably creepy Windows thing. Um, but we've resolved them. We're here. Um, we have the Go LSP installed. We have Go clean installed. Um, and I think it's time to actually try out the making a CLI on this thing. Is all I hear is Go is so great for writing CLIs. It's like the best thing for it. Nothing like it. The greatest language for writing CLIs you could ever know. So we're just gonna give it a shot. All right. So here we've got. We'll go right up a to-do list here. Basically, what the program we're gonna write here is one of my brackety programs. Basically, this is like a command line tournament runner where you provide in a bunch of like tournament entries or entrants, however you say, and then you choose on the command line which one wins, and then yeah, you just like go through each of them as like matches, and uh, like we traverse through and sort the B tree to find who is like the topmost node here. There's that one. And then yeah, that's pretty much it. It's a pretty simple program. My C implementation is obviously a little. It's not that great. I'm doing a couple things wrong that with making a CLI that I want to figure out how to do a little bit better. Like I'm not logging out just like the real output to standard out. Oh, what the hell did I do? How did I get that? Weird. I gotta figure out how to just log the real output of the program to standard out, and the rest to standard error. It's like a convention. I wanted to figure out how to make the actual interface of pressing buttons to select who won a current round a little bit easier, because as of right now it's like kind of annoying. You have to go press enter and all this crap. I would like it if I could just like get on character key down. You go in and do that. I don't know if Go can really handle that from the CLI. That's maybe not an actual CLI thing. That is like like technically like a TUI thing of like when you're already in the program, you then start handling like input to do that. And I wanted to use the arrow keys, which unfortunately went very quickly into like Windows UI territory to get that working. So I decided to not do that. But yeah, it's a pretty simple little program, and I think we're going to go through a couple of interesting things here. We'll just like we'll just yank this whole thing into and drop it into our main.go here, because I think a lot of like C programs are like backwards compatible with the Go compiler. There's some like in between layer, and I think that's the case for Zig as well, from what I've seen. So we can just drop that in there, and then I think like you can import C standard libraries and use those and treat those as if they were a Go library, which is pretty interesting. So we will play around with some of this stuff. We gotta figure out how to like go create a struct, put the struct on the heap, or do something with it. I think Go actually is Go is garbage collected, so I think you can create pointers, but not do like pointer arithmetic. Yeah, we have to do that. Blah blah, and then we have to re-implement our B tree constructor and sorting algorithm. the constructor is quite bad for the B tree because the real difficult part about making a B tree and actually like doing this like a little bit better would be to figure out how to balance the leaves because right now basically what would happen is basically just like naively tries to fill in every row kind of like left to right, whereas with a what you should be trying to do is handling the case where you do not have like a power of two number of leaves on the tree. The leaf would be like the bottommost nodes, so that would be like in our tournament here. It would be like the first round, right? So you have a problem pretty instantly if you don't have a power of two, uh, because then you're going to end up with buys, right? Um, and the kind of like the fair way to do buys is to sort of like evenly distribute where you're missing leaf nodes at the very bottom layer of the B tree. But right now, basically, if you were to call into this program with nine entrants, you would have um, you would have like entrant number nine would just get like 2 rounds worth of buys or something. Like they would be at a severe advantage because it would like they would be like a totally different branch of the tree from the previous 8 nodes, and so that's not great. But we're not trying to make something that great that actually will handle that case. Thankfully, we just want something plain and stupid, just to test out using all the parts of the language for making an actual program. That and that's pretty much it. And then we can move on to fancier stuff. So I gotta blow my nose real quick, and then we'll get right back into it. So give me 1 sec. All right. So let's get into it. So a couple things we're gonna have to do. We're going to have to create the node struct. Whoops, what happened there? We need to create the B tree. We need to get standard in to rank B tree, get standard in to get entrance, pipe winner, get standard out. And that's pretty much it. It's quite simple. After this will be just like the first thing we make with Go, just so I can get a feel for how you use the language and if it's like it actually is that good a fit for doing some of this stuff. And then afterwards we'll move on to building something a little bit more interesting tomorrow, probably through like the rest of the week to make better use of the language here. So let's see. I have here Go by example, which is linked in the actual like Go docs. There's a bunch of code snippets for doing stuff. So I want to see structs. I don't think they have like I don't think there are like classes. I think Go ditched OOP. Because like I don't see like inheritance or anything like that here. So we will just go make a struct and good. Starting off pretty good because already we're avoiding some of the horseshit you have to do in C with type defing. I mean, this kind of looks like the same, honestly. We're trading. We're making very minimal trade-offs here to move over. All right, so let's start the like Go version of this. So, cool. Oh, I don't need semicolons. Oh, that's awesome. Okay. Funk, new person. So what is going on here? So this is like the it looks like a dick. The dick operator here, I think, is the like inline create and define a new variable, but only in a function, from what I understand. So so that's what it's doing, and it's creating a new like node or person object and setting name to name. It's probably just not doing this to in here just to show you, I would imagine. I imagine there's no reason not to do it in the actual constructor. I don't know what a string is in this language. I don't know if it's like a null terminated thing or whatever. So people are just using the like default constructor, and it looks like you can just pass the things in struct order. So we don't have to make a constructor here for this. Now this is interesting that it prints out ampersand there. But like their print line automatically treats that like their format library automatically just like knows that is the address of the thing. It doesn't treat that as the actual like printing the actual address. That's a little interesting. it's kind of weird. Okay, so all right, so I don't think I have to do anything too funky here then. I think I should create these nodes and as pointers though, so that they can get we can make sure that they're heap allocated. So let's do that. Func. That's a little weird that just like the name type order in most modern languages like freaks me out. I don't know who decided to change that or why, but it's kind of annoying. Okay, so let's try. Let's see here. Dick operator equals False. Can I just provide like the first 3 parameters to it? You can try that. Okay. I should just get rid of this shit. This is gonna just make things more annoying. No new variable on left side. Undefined parent. Too many arguments in conversion to node. Let's see here. That's because this should be these should be the pointers. Or, so does it have to be here? Too many arguments in conversion to node. Oh, I'm doing this wrong. Too few values. Okay, so I think I cannot. I think I do have to provide everything, maybe? I don't know. Let's try this syntax. How about that? That compiled. Okay, all right. So we'll do create node. Create node null. I'll do like root node equals that, right? And then we'll do root node dot name equals root, and we'll try dot print line. Now this LSP does not seem to be working particularly right. I don't know if something's going on here. Expected semicolon found node. Also, I don't need to do this. I can use the dick operator. How do I pass in like an empty struct? How do I pass in a null? All right, we'll ask Mr. Copilot. Oh, nil. Okay. Cannot take address of create node nil. Okay. Well. Oh, I don't. Oh, fuck. Yeah. So they basically just make everything more brief in this language. So I don't need to do as much stuff. But I'm too used to just doing it anyway. Oh, do I need to... Oh, frick. Else. Oh, does this need to be on the same line? Oh, crap. Cannot take address of create node nil. Not import. Why did it try to import this? Let's see if that actually builds. Okay, now we have these bound. Oops. Alright, so now I have quick access to those on the correct file. That's good. Cannot take address of create node nil. I mean, is it just a problem that like all of these things are like garbage collected? So we can just create a new node here, right? I use node. Okay, well, let's just try node. Let's try to just instantiate the struct. Okay. So let's try. No, yeah, that's a better name. Food node. Much better name. Cannot take address of create node food node. Value of type node star. So is it because this is not actually heap allocating stuff that these do get destroyed here? Very possible. Okay, yes, I understand that. But I want to figure out, like, what the hell is going on in memory. When I create this struct, because that would very much explain it if that's what was going on here, right? We can ask, what the hell? Oh, caps lock. Actually, wait. We can ask, why this would be freaking out. Create node function returns a pointer to a node, so when you call it, you don't need to use the address operator again. No, but I'm trying to actually set it equal to that. All right. Wait, what? No, because I don't want this to be a root. I don't want root node to be a pointer. Is that not true? Am I stupid? The create node function returns a pointer to node. You don't need to use the address operator. So this is not a pointer? Wait, what? What type is root node? No, I want it to be. Do I not need to make create node return a pointer? Is that possible? Okay, that does make sense, right? I suppose I don't need it to do that. Okay, well, so let's try. Oh, what the fuck? Oh god. Oh, what have we done? Oh, the hubris of man. Oh, Jesus. Oh, fuck. What am I... Holy shit. Who invented this program? Get out of here. Alright. Okay. Sweet. So that works. I wonder how that looked on stream. I'm kind of interested. I think my thing is like too fucked up, unfortunately. Wait, let me see what this looks like. Oh, it doesn't look like anything. My screen like zoomed in like ridiculous. Because the stupid magnifier. Okay. Anyway, alright. So we figured out how to do this. I guess it doesn't matter that they're not heap allocated because we're returning the actual object. Yeah. Well, because if you look in this one, I heap allocated these to make sure, because I was creating them all in the scope of this while loop, right? So I need them to be, I need them to not get destroyed once we're out of scope of that while loop. And I understand and see like that. In Go, I don't know how things work. But I suppose like we're okay for right now. We don't need to figure that out yet. So we will, I guess move on for now. Heap allocate Go. New or make functions. Or when you take the address of a local variable. Hmm. Hmm. When you take the address, it may be allocated on the heap. I don't like that. I want to know. Go runtime automatically decides the best place to allocate memory based on escape analysis. Oh, yeah, that's a little creepy. um, all right. Well, maybe it will just magically work, right? We can always hope. Um, okay, fine. So let's ignore that for now and just try to. Well, let's try to do this. Let's try to pass in nil into this thing to see if that works. Okay. Oh, whoops. All right, good enough for me for right now. All right, so what are we doing? Um, so let's just create an array of entrants for now, and we can worry about passing them in to standard in later. Because we have to go create the. No, fuck it. We'll just do it now. All right. So how do I do that? So args with prog, args without prog. So it just turns them into two args already. That's good to know. Okay. Okay. So I find num entrance. They're what is this? So it's a slice. So how do I find like the size of a slice? Typed only by the elements they contain. Len returns the length of the slice. So I think so. Args go into some arg slice, right? Are typed only by the elements contained. Number of elements. I don't really know what the hell this thing is saying. Okay, capacity is equal to its length. So it's dynamic. It's like a vector. Okay, all right, fine. Okay. So I think we can find. We can grab like all of this and figure out how to do that pretty easily. So let's see here. So num entries should be like args slice blah, and then we need slice len. Where was that? Or it's len of the object. Okay. So where's that? Num entries And then I want num round, I guess provide this error condition if I did it last time. What is the... Oh, this thing's freaking out. Can't like auto format if I have like everything down here effed up. 0. Okay. Is that right for how I return something? os.exit makes the exit program with given status. Okay, you try that. I'm glad it auto imports that for me. That's very helpful. Oh, interesting. So, okay. Okay, alright. So, that. So, then we have to figure out how to do some math here. Equals seal. Alright, where's the math? Yeah, this is one of the problems with this language, is that looking up stuff for it it's kind of annoying. Alright, so I want to find, I need seal, and then I need log2. So it looks like okay, good. The convention is basically just everything is uppercase though. Okay. And we will just assume that this will work. Okay, so I need math probably as well. No? Do I need like math dot? Type int as float 64. Oh, I can't like, can I like cast that? Why are these all floats? How do I, let's look that shit up. Oh, where did my copilot go? Come on. So, oh, okay, so it's wrapped like that. Alright, that's fine. Yeah, so in trying to make these constructors less verbose by having them auto type. Oh, also, whoops. We had to add this fucking wrapper thing to do it. So it effectively has saved us no time at all. Is what I'm seeing here. Unfortunate. Okay, let's figure out how to do that. So now we're here. We can actually make the tree. So let's do that. Okay. I wonder how much I actually have to change to like get this to work. Ah, crap. I do have to go to the restroom real quick. So I'll be gone for just a moment. We'll come back and we will finish making this beach reconstructor. Alright. I'll also get some tea. So it is very amusing to me that this converting from C to Go is basically just removing parentheses and semicolons out of my code. I wonder if I just do this slash, like if I just do some of these, will that work? Not quite. We're pretty close though, I bet. Alright, I might have to pop off for a call actually, so the stream might be ending shortly here. We'll see. Okay, so what actually did it not like? While cur leaves is less than num leaves. Oh, because it's the wrong type now. You know what? Yeah, because this should not be the type. We should take it as float here. Actually, I don't know if I even need to do that. All right, I think we're done for the day. Unfortunately, we're getting called, so we will pick things up again some other time. Thank you for watching.